Here we go. Here we're going. You gonna do the fun bun?
Yeah.
Okay.
It's hot in here. It really is. That's like
There it is. Fan bun. Okay.
Fun bun. Sorry.
Oh, so it's the 26th of September. This is Math 1, and we're talking about life into graphs. What we're going to do today is we're going to look at some real life situations, and we're going to turn them into graphs. I'm going to give you a piece of paper. You are going to fold it, but only in half this time. Not 4 boxes, just a pure in half. And then you're going to start making this graph. I'll project it on your graph paper. Here comes the graph paper. Yep, and rulers, absolutely. It's ruler again. You got that one last time.
I just know it's the one I have last time because I'm working and then you said.
There's another one.
And then the team you play for?
Yeah, it's the team me, Nico,
I.
Nico, Trent, and I.
There we go, nice. Cool. Okay. You need another piece of paper? Take your piece of paper, fold it in half. Open it up. Draw a coordinate system. Looks like this. Every 2 boxes is 1. So 1, 2, 1, 2, 3. Nice. Okay. And I like that some of you are labeling it. We're labeling it with height and seconds. Hey, oh, you're not. You are not following instructions. So we're going like this, and you're drawing this. Who's on the floor? I picked it up off the floor. Label it with 1, 2, 3, 4. That's good. Label this with height, and that's time. Good. Label it with height and time. Right about there. This is a lesson that's going to get me fired. Either that or it's the one that they're gonna call OSHA on me. So OSHA is occupational safety and health or something. It's one that's supposed to keep you safe at work. So here we go. Hopefully you got that graph ready. Right now, at time 0, how far off the ground am I? 0. At time 0, I am 0 feet off the ground. So on this graph, right now, at time 0, I am right there. Correct? Good. So we're going to model the next few minutes of our life using a graph. We're going to assume that this ladder is 6 feet high. It's not, but we're going to go with that. We're also going to assume that each of these steps is 1 foot. So this is 1 foot. So how high am I right now?
1 foot.
Here we go. Right now, I'm at 0 feet, 0 seconds. 1 second. 2 seconds. 3 seconds. So over there on that graph, at 3 seconds, where am I at?
3 feet.
3 feet. Can you put a point at 3 feet? 3 seconds, 3 feet. I'll put on mine. So 3 seconds, 3 feet. We just modeled what I did on the ladder. 0 seconds, 0 feet. 1 second, 1 foot. 2 seconds, 2 feet. 3 seconds, 3 feet. Now, I'm just going to hang out up here. I'm going to hang out up here for 1 second. What does that look like on my graph? Just hang out. What? Tell me. Show me with your fingers or something. What's it going to look like? There, I like that. It's a plateau, isn't it? So I hang out here for 1 second. Graph that. Zero seconds. I keep rewinding, so I'm back to 0. 0 seconds, 0 feet. 1 second, 2 seconds, 3 seconds, 4 seconds. You with me? Now, here we go. I'm gonna go really fast down here. It took me 1 second to do that. I climbed back down my 3 feet in 1 second. So where am I?
5 seconds at 0 feet.
Boom, right here. Alright. 0 seconds, 0 feet. 1, 2 seconds, 3 seconds, 4 seconds. Back down to the bottom. 5 seconds. Okay. I'm going to hang out down here for 1 second. 1 second. Put that on the graph. Hanging out for 1 second down here. Alright, here we go, Turner. 0 seconds, 0 feet. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. Is that where I'm at? 6 seconds? Okay. Now, 2 seconds all the way to the top. Ready?
Ten.
2 seconds all the way to the top. Get me in there. Can you get me 6 feet up? 2 seconds all the way to the top. The camera's cutting off my head. Okay. The next part you're just going to have to imagine. because I'm not really going to jump off the ladder because that,
That would be bad.
like, this isn't stupid enough. Okay, so 2 seconds, I'm up at 6 feet. Two seconds. 1, 2, 6 feet. Did I go up too high? I went up one too high, didn't I? Right about there? Okay. Have me hang out up there for 1 second. I hang up out at the top for 1 second. And now, using your imagination, because I need to be able to teach for another 15 years, imagine I am on top of the ladder. I jump off the ladder. It takes me half a second to get to the ground. Put that on your graph. Half a second to get to the ground. I think we're at 9.5, so that would be. There it is. What'd you think of that, Lily? Yeah?
I was so confused.
Now, we just modeled it. We modeled a real life situation on that graph, but we can read the graph. Using words like you're climbing up slowly, you're climbing down quickly, you're jumping off. Use words like that. Tell me what's going on right here. Raising a hand. What's happening right here? Raising a hand, Jackson.
You're climbing up slowly.
Good. What's happening right here? What am I doing?
You stayed there for some.
Kind of just hanging out. Okay. What's happening right here?
You're climbing down.
I'm quickly or slowly? Quickly. The steeper the line, the quicker I'm moving. What's going on right about here, Jordan?
You're down for 1 second.
Yeah, I'm just kind of hanging out, right? I'm not climbing. I'm just hanging out right there. Micah, what's happening right there? I'm going up fast. What's happening right here, Greenlee?
You're just hanging out up on top.
Just hanging out on top. Looking like a gargoyle a little bit up there. Okay. And then what's going on right here? Gavin?
You jump down
I jump down. So am I moving quickly or am I moving slowly?
quickly.
Moving quickly. All right. Questions on what just happened? We're going to do another one. Yes.
Did they allow you to get on the ladder?
Who's they? I guess they did because I was on the ladder, right? Mm-hmm.
Rebel.
Nobody can see you.
It's probably not the best thing to be doing. We're going to do another one. But this one, I'm not going to tell you how to number it yet. We're gonna watch a video and then we'll start getting the graph ready to go. So do not get the graph ready to go yet. We'll do it together. one of those jumps.
I wanna do that.
Before,
I would get hurt.
before we model it and create a graph, we're gonna look at it in slow motion, and we're gonna determine how big our graph has to be. Like how many seconds do we need to get out to? On my ladder one, we got up to 10 seconds or something.
Yeah.
So we gotta think ahead of time. We can't just start drawing it, because what if we only make it out to 5 seconds when we really need 10? How high did my ladder go?
6 feet.
6 feet. Is this going to have to go higher than 6 feet? Yeah, those guys are jumping way higher than 6 feet. So here's the one we're going to do, and let's figure out how to even build the graph, the scale for it. Let's pause right here for a second. Pause it. Let's just look at this ramp right here and use that for scale a little bit. How tall do you think this ramp is?
10 feet.
So we're going to go with 10 just because it's an easy number to work with. So 10 feet. And now, based off of, if this is 10 feet, let's try to figure out how high this person goes.
I think it's person with like, it's like
Probably like
It's like
80.
40.
it's like 40.
40.
It's 8.
Is there like 8
It's 8.
40.
I'd say
I'm saying
45
80.
maybe.
I feel like
1 million feet. Okay. Well, let's look at the time. And the entire jump takes about, so 11 seconds. So how do you want to scale this? We need to get up to how high?
Like 80, 60.
Let's go by.
We're gonna go with 40 feet. Okay,
I was right.
40
Let's go by
feet.
5.
So I like it. Here's how I did it. I went that every 2, and I'll project it. Every 2 is a 5-foot increment. And then I went out to 11 seconds in the same way that we did seconds before. Let's see right here. So I said 5, 10, 15, 20 like this, and then coming out every 2 is a second. So get that graph ready to go. Label it with time and height again. Time is the x-axis, height is the y-axis. You're going to repeat after me. I will not draw in the line until Mr. Barr tells me to. We're going to just plot the points right now. We're going to plot the different points, and then I'll help you draw on the line. It is not a connect the dot. This is not a bunch of linear lines like the first example. What we see here are curvy lines. Because as people go up, they slow down, and they come back down. Is this, when they went up in the air, was it like this? Up, down. No, it's curvy. Things are fluid and slowly changing velocities and accelerations. So let's start with right there. Oh. Let's say that the water level is 0. This is 0. Actually, let's call the bottom of the ramp is 0. Where's he at?
A little bit over 0.
Give me a number. At 0 seconds, where is he? He's not at 0. If this is 0 feet, he's not at 0 feet at 0 seconds.
Probably 5.
How about this? At 0 seconds, he's at 5 feet. Because isn't he actually, he's coming down a hill, so isn't he above, if this is 0, so give me a point at 0 seconds, 5 feet. How high is he?
0.
He's at 0. He's 0 feet, and what's the time? Let's go with 1.5. Is that good enough? At 1.5 seconds, he's at 0 feet. Can you plot that?
Wait, what? Is that 5 or 7? 0 feet, that's 5.
At 0 seconds, he was at 5 feet. Now, at 1.5 seconds, he's at 0 feet.
Okay.
Where is he right there?
10 feet.
And let's go with 3 seconds. He's at 10 feet. A little bit of rounding there, but at 3 seconds, he's at 10 feet. Can you put a point there? Now we've got to figure out when he hits that high point of about, we're going to go with 40 feet.
But he jumps off like when he gets that.
We're counting him, not the bike. We're going to pretend like it's pretty much his, let's go with his feet, kind of. It's not exact. Over there? Okay. So at 6 seconds, he's at how high?
40.
40 feet. We'll go with 40. It's not exact, but it's good enough for us. Are you connecting the dots? No, because you said you weren't going to connect the dots. You said, I will not connect the dots. And you are not liars. And let's bring him down. Let's call him, how high is he now? About 0, back to 0, and we'll call it at 11 seconds? Or 10 and a half. Can you go half seconds on that?
Yeah.
Whatever you want to use. When I throw this into the air, this marker, does it go up like it's going at 5 meters per second, and then does it just immediately stop and come back down? No, it goes, what's it doing as it goes up? Slowing down, and then now what's it doing? Speeding up. So if I actually graph that, it's this curvy thing that it's actually slowing down. The height is slowly getting higher, and now it's coming down again. So when you curve this thing in, I want to see curvy lines, because it's not just up and down. It's going up and it's slowing down, and it's coming over the other top, and it's speeding up. So curve this thing in. All kind of curvy lines. Curvy lines. looks a little bit goofy, but it's your first shot. You get it out. So it would be really, because what just as long as doing is say, hey, get out here, and he kind of just, like he was just like, I'm at 40 feet, and it's going to be at 40 feet for a couple seconds. And he's not. You're good. Don't worry about fixing it, but it's going to be a little bit curvier than that. A little bit curvier. Ah, nice. That's pretty good. That's pretty good. Yeah, stuff like that.
Actually, this one looks. That trip down there is really clean.
That's pretty good stuff. Very curvy. And that models kind of what was going on. Now, recognize this isn't showing the jump and stuff. What it's showing is height and time. It has nothing to do with how far the guy is horizontally. This graph doesn't show horizontal at all. It tells us height and stuff. This exact same graph could be used to just like model a ball being thrown straight up into the air. Actually, it really does. It's a marker. I have a marker in my hand. How high is it above ground right now? 5 feet. Okay, ready? I'm gonna come down. Where's the marker right now? 0. I throw the marker way up in the sky. How high does it get up?
30 feet.
I think 40 feet. 40 feet based on this graph. And then it comes back down. Notice this graph has nothing to do with the horizontal. It's all about time and the vertical. Even though it kind of looks like the actual jump, doesn't it?
Yeah.
But just because it doesn't, it's not anything to do with the horizontal. It's all about the vertical. Let's do another one. Do not flip your paper over. You can start the graph, but don't number it yet because you don't know how to number it. Start the graph, but don't number it. It's a good day.
It's an okay day.
No. It's a good day. It's a free dress day.
Not for my class.
That's
For
Not for your class? Who's your class?
Mr. Best's class.
Oh.
Is it Mr. Best mad at you because you paid for your
Okay, he can be mad all he wants. I saw $20 bills in the other classes too, so some people are throwing in big amounts of money, right?
Yeah.
So why is it, so if a kid throws in a $20 bill, that's okay, cool,
Yeah.
right? But if a Mr. Barr throws in a 50 because I wanted my class to get something else done, that's wrong? No.
I think he just salty because you want to eat your class got like $50 and wearing all the shirts and he was like $2.
Yeah, and I got all my kids to wear their house shirts, and that's it was worth $50 for me, which is going to a family in Mexico to build a house, which is something I would contribute to anyways. I mean, it's not a. Yeah, I mean this is good stuff, regardless. Yeah. All right. So here's our next one. So we're going to model one of those dives. And before we get too far, we're going to figure out the time and the height required for this. Now I am telling you that it's a 3-meter board, the height, so it's 10 feet. And I've put this at about water level, so this is 10 feet. And then we're gonna see how high he gets. And we're really dealing with the height of his feet more than anything. So right there, you see how high he got?
Yeah.
So I feel like we should be able to get up to, how high would you have this thing go?
15.
Well, this is 15 right here. So this is
Oh,
5,
one.
10, 15. Can we take it up to 20? And then the time. It's about 6. So here's how I did mine. So over here, I went by ones up to 20-ish. I got up to 18, that's good enough. And here, I went up with a little bit different scale. I went every 4 is a second. That means I can actually get down to a quarter of a second pretty easily. A fourth of a second. Let's graph this. You cannot see it. At 0 seconds, based off of the guy's feet, how high is he?
10 feet.
He's 10 feet. At 0 seconds, he's at 10 feet. Plot that. Oh, and promise you're not going to draw the lines yet. Okay. Promise me, go.
I promise.
At 0 seconds.
At 0 seconds, he's at 10 feet. He's 10 feet above the water. He's right there. 0 seconds, 10 feet. Where is he now? Still 10 feet. He's plateaued, isn't he? Like the ladder. Where's he right now? 10 feet? Oh. Okay. Right there, where's he at? He's at 10 feet. He's about to jump though. So let's put a point right here. Give me a point at 1.25 seconds, 10 feet. 1.25 seconds, 10 feet.
There's 2.
1 second? But you can do a 0.25 really easily on that graph, can't you? Because you've got 4 spaces for each second. So 5 squares over. Does that make sense? You got a 0.25. Cool. So 1.25 right here. You gotta go up to 10 feet. This is 1 second, and then a quarter second. You with me? So that graph, we set it up really nicely to do this. Now he's about to take his first jump. So let's see how long it takes him to get to the height of his jump. There he is, right about, boom. So let's call this, how high do you think he is right there? 12, okay, let's go with 12. And what time would you use?
7.5.
1.75. Let's go with 1.75 at 12. 1.75 seconds, 12 feet. And he's going to come down. Oop, he just made contact with the board. Let's bring him down. The board's going down there. So now the board has actually gone down below. So where would you put him now?
9.
9? Let's go with 9 on this one. And at what seconds? 2.25? 9 feet at 2.25 seconds. So he's at the bottom of the spring of the board, and now it's going to throw him back up above the board. Right about, boom. Where would you put him right there? That's 10. 13? At what time? 2.75? 13 at 2.75. Right, here he's coming back down. We would put him at 8 maybe? A little bit further down than the last time. So 8 at 3.5? 8 feet at 3.5? Yeah, got it. 8 feet at 3.5.
Weird.
But it's modeling what he's doing. It's telling us his height at every time. Now see how high he gets? Right about there. He's at the peak. And I'd probably put him at 18, 19, somewhere 18, 19, 20. Your call. At 4.25. Let's get him into the water. And water, and right there. How high is he? 0. What time? 5.25. Are all of these motions really linear, like boom, 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 boom? No. Is it all really curvy? It's all really fluid. So you're going to curve this out. He doesn't go down to the bottom of the diving board and then instantly come back up. No, it comes down slowly and goes up and it comes down. It's like a roller coaster. A really smooth roller coaster. Curve it in. Well, the flat is just flat. That's flat, 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 and then curvy.
Also, like the first 2 points right here, do those flat.
Yeah,
Then you
that's
jump up.
Yeah, but even that jump, it's not an instantaneous jump. I mean, he jumps up, but there's some slowness. So curve it up. It's not a connect the dots. It's not a connect the dots. It's very curvy. Even the bottoms are curvy. Everything's curvy. When he comes down to the bottom, it's curvy. When he goes over the top, it's curvy. Curvy. Everything's curvy. So even these would be curvy. Even the bottoms would be curvy. Because when it's not curvy, it's saying it's like an instantaneous change. He's going down and instantly he's going back up. No, he's going down and he's slowing down, and then he's speeding up. Curvy, curvy. Let's see how curvy. Curvy. It's a little bit painful. I'm looking for a really good curvy. Even these would be curvy down at the bottom. Everything would be curvy. So, if I were to do it, mine isn't going to be perfect, but what do you think? Is that kind of what yours looks like? Is that close to it? So here he is. He's running up. He makes his first jump. He goes up and he's coming back down. He's down right here on the spring of the board. It throws him up a little bit higher. He comes down. It throws him up even higher. He comes up, he's flipping. And actually right here, I need to have him come down a lot farther, don't I? There. Very curvy. Right here. Right here. Is he on the diving board right here?
No.
No, he's above the diving board. Where is he right here? He's on the diving board. Where is he right here? Up, he's flipping. Where's he right here?
In the water.
In the water. Where's he right here?
On the
Diving board. It totally tells us what he's doing. It models that real physical thing in life. Questions? It's pretty good, isn't it, man?
Yeah.
I did that last night.
How long did it take you, like, do the timing and then all that?
For both videos, I did both videos last night. I've used them in the past, but I didn't have all this good stuff on it. It took me about an hour to generate the videos last night. This took forever to try to figure out how to make this scale be in the right place here and there, because this had to match up with the diving board and the water. That took a long time to
How did
figure
you
that out.
Yeah.
And then I tried to export it, and it didn't export. It was weird, but pretty good.
You got it.
Pretty good.
Beg your pardon? I can look at it. Hey, you guys can start on the homework.
I'm really confused. I'm so confused. No, I'm so confused.
It's not even about this. It's the entire on stage.
Were we supposed to put anything in there?
No, everything was on the graph paper.
It's
It's yours. Throw it away when you're done. All right. Don't call OSHA on me. Hey Lily, leave a comment. Like, what? Does she subscribe? Does she? Good. You should subscribe.
Subscribe. Yeah,